So we have this relation divides on the integers, pair x and y, where the first element divides the second element. We have another relation on the integers, and this relation would also work for the real numbers. We could also talk about less than. Less than is also a relation on, you would have, let's call it L, is the set of pairs consisting of integers x and y, such that the first is less than the second. So can you give me something that would be in this set? 1, 2 would be in this set. 8, 9, sure. What would not be an L? 5, 4 would not be an L. So here's another example of a relation, and of course you've seen this written differently. Instead of saying 1, 2 is an L, which you would have said in previous classes, and we'll say sometimes in this class is 1 is less than 2. But these mean the same thing because of how L has been defined. If you have a finite relation, it's possible to visualize it using a table or a directed graph. Now I can't do that here, but if I look at my original example where I defined R to be 0, 0, 1, 1, 0, 2, because this is finite, the set S, I can list out 0, 1, and 2, and then I can think about putting some kind of symbol here if this pair is in the relation. So 0 is related to 0, 1 is related to 1, and 0 is related to 2. And I can visualize it that way. Another thing I could do is I could think about drawing circles, and then I put the elements in the circles, and I could draw an arrow from one element to the element that it's related to. So if I did that for this relation, it would look like this. Finite relations pop up a lot in computer science, but this gets into directed graphs, which you'll see when you take discrete structures or data structures and algorithms. A directed graph gives you a relation on a finite set. I'd like for you, I realize you just saw relations 5 minutes ago for the first time, so I'm going to give you one more, but then I'm going to ask you to try to play with it a little bit. Now, if you can come up with just some examples of relations, either finite or infinite. So let's look at one more. Say we have the new one, which I'm going to call M, which is the pairs of integers such that x plus y is equal to. So for now, here's the thing. When you have this kind of relation, which is a subset of the integers cross the integers, then what you can do is for this type of relation between integers, you can think about graphing it on like a grid. For instance, 1 plus 8 is equal to 9. So I would have the point 1, 8 that I could plot here. I'm only dealing with integers, so the next one I would look at would be 2, 7. And I can sort of visualize, yes, this is all of the points. And I think about, oh, this looks like the line, right? If I think about it for a minute, I realize this is the integer points on the line, y equals 9 minus x. So when you're looking at integer things, sometimes plotting the points gives you some insight. So now you've seen 3 examples of relation, actually 4 examples of relations, 1 defined on a finite set, and 3 defined on the integers. And I'm going to ask you to try to come up with a couple more.